Hello, fifth graders. Today we are looking at how to use models to multiply a decimal and a decimal. The objective or your learning mission is to use grids to multiply decimals. Now, this sounds super intimidating, but actually it is super fun. Okay, if we have, and write this in your notebooks, 7/10 times 8/10. Now, from our last lesson, we learned that we would locate our decimal points, count how many digits were behind those decimal points. So we have one here and we have one here, one digit behind the decimal, one digit behind the decimal, which would give us a total of 2 digits behind the decimal. And that's how many times our decimal point would move. So 8 times 7 is 56. And the decimal point would move once and twice, which would give us a final answer of 0.56 or 56 hundredths. Now, how would we use this grid to show this? Well, let me show you how much fun this is. So first, let's focus on the 7/10. Okay, we're gonna take, if you remember, this is a hundreds grid and it equals one whole, but then one of these is a skinny, right? And the skinny represents 1/10, which is 0.1, which also equals 1/10, 1/10. So we need 7/10. So how many of these are we going to shade in? Well, we got 1, 2, 3, 4, 5, 6, 7. And we're going to shade all that in. Shade, 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 shade. Okay, now we're going to switch colors. We're going to do some green. Now we're going to focus on 8/10. So we just went actually up and down, which is vertical. So with the next number, now we're going to go horizontal. So here's our first skinny, horizontal. So that is 1/10. But remember, we need 8 of these. So that's 1, 2, 3, 4, 5, 6, 7, 8. And we're going to box that off for our 8/10. And we're going to shade in all of that. Okay, so now we want to focus on which boxes have both red and green in them. So I'm going to highlight those. So this has red and green, red and green, red and green. That stops right there. Red and green, red and green. So these boxes here in the yellow are the only boxes that have both red and green. So now we're going to count them. So we got 1, 2, 3, 4, 5, 6, 7, 8. Now I could use multiplication, right? We know it's 8 going down, and then we got 1, 2, 3, 4, 5, 6, 7. So I know I could do 8 times 7, which is 56. And I know that each of these squares is a hundredth, so that would be 56 hundredths. And guess what? Look at our answer from our standard algorithm, 56 hundredths. But just to prove this, we're going to count it out. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56. So if you don't believe me, you can count them out. But I think the easier way to do it is just to use our area formula, which is length times width, right? So over here we got the 8, over here we got the 7. That gives us 56, because 8 times 7 is 56, but remember it is hundredths squares. So we need the decimal point there. All right, let's try another one. All right, we're going to try a bigger one now. I put 200 blocks next to each other, so this is a total of 2. But let's take a look at 1 7/10 times 5/10. Okay, if we wanted to solve this using the standard algorithm, we're going to locate our decimal points. We're going to count how many digits are behind each one. So that's 1 digit, that's 2 digits. So that's a total of 2 decimal places that we're going to move. 5 times 7 is 35. We're going to carry the 3. 5 times 1 is 5, plus 3 is 8. We're going to move our decimal point those 2 spots. 1, 2. So our final answer is 85 hundredths. All right, let's see using shading if that works. So first, let's do 1.7. How are we going to do 1.7? Well, 1 would be 10 tenths. So we need 17 tenths, right? Because this 1 is 1 whole. So that would be these 10, and then we need 7 more. 1, 2, 3, 4, 5, 6, 7. So if we count it, there'd be 17 tenths, which makes sense that this is 17 tenths because we would read it 17, and then what place value is the 7 in? The tenths place. So you could read that as 1 7 tenths or 17 tenths. All right, we have our 17 tenths or 1 7 tenths shaded in. And then we need our 5 tenths shade. Oh, let's shade this real quick. And then we have our 5 tenths. So we'll go green here. 5 tenths, so we just went vertical up and down. So now we have to go side to side. 5 tenths, 1, 2, 3, 4, 5 tenths. And we go all the way across. And then we shade in. Okay, now locate where this is where they are both inside. And we're gonna block that all off, going all the way around. Now, I don't wanna count all those blocks. So we're gonna use our area formula to do that. So remember, area equals length times width. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 times 1, 2, 3, 4, 5 times 5, 17 times 5. That looks really familiar, right? That's what we did up there. So once we solve that, we get 85. Well, but that's not the answer, right? We know our answer is 85 hundredths. So this actually isn't 85 because it just tells us how many of these squares there are, and that's 85 squares. Well, how much are those squares worth? Well, each square is 100th, or 100th, like this. So the way we would read this 85 is 85 hundredths, if each square is 100th.